Tangential velocity. So let's start out quickly by talking about what does tangent mean. It's a term you might have seen in geometry and trig, but that was some weird trig ratio, right? It was opposite over adjacent, but that's definitely not what we're doing here, right? So if we recall from last semester, the word normal, like a normal force, means perpendicular to the surface. So tangent is perpendicular to that. So if I have a flat surface, the tangent line is just along the surface. But if I have a curvy surface, lines are tangent to a point, not the whole path. Okay, so what does a tangent line look like then? On a circle, all right, it intersects the circle at one point and one point only. If I have a different kind of shape, say I'm looking at a function, the tangent line will intersect and be perpendicular or be parallel at that point, so it's perpendicular to a normal force, say at that point, but it might end up intersecting the function somewhere else. That's okay, we're only looking at that one single point. Now, how do you remember the difference between normal and tangent? Well, here's what I like to say. Why can't you be normal? You're always going off on tangents. Okay, back to work. Let's talk about tangential velocity in uniform circular motion. What this means is something that has a constant period. So it has a constant speed. The velocity is only not constant because it's changing direction. Okay, we're going to assume that we know the period of this motion and the radius of the circle. Now, in this case, the tangential velocity is going to be equal to the instantaneous speed. So what that means, speed is distance over time. How far does it travel, say in the stopper in our activity in class, how far does the object move in one period? Okay, it moves around the circumference. Well, what's the equation for that? It's 2 pi r. And how long did that take? Well, it took the period. So here's the derivation of that. Okay, so the instantaneous speed is equal to 2 pi r over the period. Now, this is also going to be equal to your tangential velocity magnitude. The direction is in the name, it's tangential.